Welcome everybody. We have this interesting question. We are expected to find the area. Foremost, we need a quarter circle. We are expected to find the area of this region. Okay. Now this region is sandwiched between the semicircle and the quarter circle. So this is center. This is also a center. Okay. Now foremost, this distance is given as 8 units. So since this being a square, the diameter of the semicircle will be equal to 8. So this means AD will be equal to 8, and if I take this point as sum O, OA is OD is equal to OD is equal to 4 units. Okay. Now we see that there is a point of tangency. There is a point of tangency between the quarter circle and semicircle. So and they are in contact externally, and so by external tangency theorem between two circles, we know that the line drawn through the point of tangency will pass through the centers of the two circles, right? The dot is on top of I. Okay. So if I were to connect these two, or I would say pass a line through the point of tangency, there's a point of tangency here, then that line would pass through the centers. So there is a point of contact here, there's a point of contact here. I would say the line is passing through this centers O and B. So that means there is a right triangle that has been created. Okay, that is fair enough. Now clearly there is a right triangle here. You see that right triangle here. So if I were to pass this line, definitely this line is going to be a bisector of this right triangle, and this is going to give me a 45-degree angle. So this is already 90, so this is going to be 45 degrees. Now I need these two angles. Okay, fair enough. Now required blue region. Required blue region is equal to what? The area of the triangle, OAB, from the area of the triangle, I am going to subtract sector. Say, let me have this point of contact as some T. Sector OAT plus sector, say, let me have this as Q. Sector BQT. So these two sectors I'm going to take away, right? So if I take away from the triangle, if I take away these two sectors, I will get this. So this is a lovely question, and Let us do that. Okay. Now, more importantly, we need the radii. So if I were to take this as r1, and clearly this distance is going to be 4 units. I know this is going to be 4. Why? Because OA is 4 units. But the main point is we need to get this radii r1. So if entire distance is 8 units, and if I were to take this as r1, then we need to create a equation, right, to represent r1 so that we can use it. Okay, so what I'm going to do is I would be considering a triangle AB. There's a 90 degree there, and O. So this distance is 4 positive. I am taking it as R1, and this distance is 4 units. This distance is 8 units. So since the triangle OAB is right angled by Pythagoras theorem, we can now have OA squared plus AB squared is equal to OB squared. This is 4 squared, this is 8 squared, and this is 4 positive R1 whole squared. I use A positive B whole squared formula, which is A squared positive B squared positive 2AB. This is 4 squared positive 8 times R1 positive R1 squared. Now this is 16 positive 64. So with 64 you add 16, you get 10, 1, 80. You have 80 is equal to 16 positive 8 times R1 positive R1 squared. You move this to the right. So you get R1 squared plus 8 times R1 positive 16 negative 80. So from 80 you take away 16, you have a 10 and a 4. From 7 you take away 1, you have 6. So you're getting R1 squared plus 8 times R1. Negative 64 is equal to 0. Use quadratic formula. A is equal to 1, B is equal to 8, and C is equal to negative 64. The formula is R1 is equal to negative B plus or minus root of B squared negative 4AC divided by 2 times A. My B is 8. 8 squared is 64. Negative 4 times my A is 1. My C is negative 64 divided by 2 times of A. Now 64 times 4. 4 was a 16. Carry 1, 24. 256. To 256, it's positive sign, right? You have to add 64. 10, 1, 6 added with 6, 12, 1, 320 you are getting. So negative 8 plus or minus root of 320 divided by 2. Now let us fragment 320. 8 times 40 and then 8 times 5. So you have 8 root 5. So it's going to be negative 8 plus or minus 8 root of 5 divided by 2. This is going to be, it's a negative sign, right? So negative 4 plus or minus 4 times the root of 5, right? 2 is dividing. I cannot take a negative value, so this will be the only value for R. So R is equal to negative 4 plus 4 root of 5. So let me write that down. R is equal to negative 4 positive 4 times the root of 5. So this is the value of R. Okay, now having got that, so we will have to place that there. Now the question comes to get the sector, okay, and then get this sector. So let me do that. So this sector is easily obtained. So area of sector OAT is equal to theta over 360 pi times r squared. Theta is 45 degrees and r is 4 times 4 because r squared. So 4 divides here what? 90 times, and 9 divides here 5 times, so 9 divides here 10 times, right? And 5 divides here 2 times, 2 divides here 2 times, so 2 pi is the sector area. Now go back here and we need to get this sector area. Okay, sector area of BQT, area of sector BQT, what is that? Theta over 360 multiplied with pi r squared. My theta, as I mentioned to you, 45, 360 pi. My r is going to be -4 plus 4 times root 5. Am I right? So let's check that out. -4 positive 4 times root 5. So this is 45. If I were to use 5 divides here 9 times, 5 divides here 7 times and 2 times, right? 9 divides here 8 times. So this is going to be, I'm taking 4 out, it's going to be -1 positive root of 5 divided by 8. So 4 divides here 2 times. So this is going to be pi over 2 of -1 positive root 5. So this is for the sector area of BQT. Now from triangle, base is 8 and height is 4 units. We have to take away these two sectors. So now I'm going to write area of triangle. What is the triangle? Triangle is OAB. Triangle OAB is half times base into height. My base is 8 units. My height is 4 units. 2 divides 2 times 16 square units. So therefore required blue region is equal to, from the area of a triangle, you take away the area of two sectors, S1 and area of sector S2. So this is going to be 16 negative. The first one is 2 pi, and we have to add this pi over 2 of -1 positive root 5.